features for doing real-time analytics with Spring Cloud Data Flow, in particular with image processing, computer visions, cool stuff for detecting objects and detecting images in general. For the purpose of my experiments, I built a few simple components that would allow me to stream video and visualize and project video. So this simple stream would illustrate how you can use those. Practically, the webcam component would use the camera of your computer, and this is a simple player that can show the images passed from and captured from the webcam itself. Let's create and give it a try. You can even deploy it. Another interesting extension of this to use the camera in order to detect the QR and some open source libraries out there. So we're going to do very similar pipeline build right now, but instead, before we log the output, we're going to pass the output of the camera to a reader and then put it into the log file. We may also want to visualize what we are scanning. Image viewer. Let's also stream this to let's be the viewer component. So now from our web cameras, we're going to pass it to the QR reader to detect the code and send the text representation to the log file. At the same time, we're going to visualize what the camera is passing to the QR reader itself. Let's create this stream. And deploy it. While deploying, we can open the log output, so we're prepared. We are ready. Let's now, I have prepared a barcode. See? I do agree that Spring Cloud Data Flow rocks. What else we can do? Let's do a little bit more advanced now and jump into the computer vision and use some of the state-of-the-art algorithms for deep learning for recognizing objects and images in general. Let's stop current streams first. Cleaned. So the first algorithm is based on the GEOT, the Google's TensorFlow's inception model. This is one of the state-of-the-art model for image recognition. So we're going to build a pipeline that takes pictures or video images and pass them through this TensorFlow model processor in order to determine what is on the image as a text representation, and we're going to print this as in the log. So let's create the first pipeline that would take actually files from a folder like this. Inception model, okay. Okay. Here is the output folder we would like to monitor. This is where the messages would be printed. Okay, the log component is started, and if you remember, this stream would expect a file. Let's plot it again just to illustrate. From a predefined folder, it's reading images, pass them through the image recognition processor, which underneath uses the Tensorflow inception model and prints on the log the recognized images with their perceived probabilities. Okay. Deploy those models. Actually we already have the panda in this folder. Let's see. Good example. So practically it printed it, but it's in binary format, and because it is using a tuple model underneath. Let's redeploy it, and this is a good exercise. Practically in this case we have to specify that the input format content type is actually not text, but actually it's the tuple format itself. It's binary representation of the tuple format. So deploy, second attempt, again, output. Okay, it actually recognized that it's with a high probability, almost 98% giant panda. Let's do something more interesting. Let's go to dogs. Let's find some dogs images on the Google and try to recognize what. Save this image on the this folder. And actually it suggested that this is a Labrador retriever, golden retriever. So you get the idea. It's pretty fast algorithm, by the way, compared to the other I tried with. So and you can retrain the model. It's based on TensorFlow. You can retrain only the latest layer if interested. Actually, there are different frozen or pre-trained model you can experiment with different accuracy from the TensorFlow site itself. So you can find a lot of information how you can train or extend the existing model so that you can recognize specific objects that you might be interested in. Next interesting model is something recently added by again by TensorFlow. It supports object detection. So apart from detecting a single image in the single object in the image, can't we actually detect all possible objects? And that's different TensorFlow model used behind, which is far more intensive as a computation. Let's try this. We would start with similar approach. First, drop from a files. You see, from a file, when you drop a picture in this folder, it would be processed by the object detector, which is yet another TensorFlow model, which is you can download. There is various properties you can specify. Okay, I just confused myself, but you can specify the location of the model, the labels that have been categorized, and the object would be visualized in the viewer with the model, so that the objects inside should be in rectangles, and the textual description of those categories would be sent to the log. Let's create the stream. Deploy. Here I'm going to add a little bit more memory to to this node, to the node that actually runs the model, because the model could be a few hundred megabytes, the pre-trained model. Also, let's deploy the second pipeline that would read the textual description and send it to the log. Okay, let's open the log output. The image viewer player is coming as well. We are expected to read files or to provide files in this folder. Let's wait for all bits to start. It's this folder, and I have a couple of pictures already. Let's start with something like this. Oh, okay. You see all those multiple cell phones have been recognized, which is cool. Let's try with a different picture. And here is the list of the phone. This is the textual representation. This is the phone, the probability, and the coordinates of the box of the object itself. Let's do something interesting, like this: backpacking tourists. Oops. It takes about 10 seconds, 15 seconds for this model to actually process the picture on my laptop under given conditions. And here it is. We have 5 persons and their backpack being recognized. Pretty cool, isn't it? And now let's do it try to make it even cooler, or not, depends. We're going to actually try to real time using our web camera. And this would be the last experiment. I'm going to run. Okay. Here even my laptop behind. Not sure what is this. That's, as I said, okay. My coffee cup as well is in the picture. I think it's pretty cool. Even my chair has been detected on behind. I think this is a good start and good demonstration for real-time analytics and detection. You can see how many opportunities you can build you can build on top of those components already in very interesting use cases. So hopefully this work would come either as a part of the standard Spring Cloud data flow app starters, or as one of the samples that accompany those.